Welcome back, teachers. Today we're talking about section 13-1, linear measure. This is part 2 of the lecture. In part 1, we discussed the English units or standard units and the metric system. We talked about dimensional analysis, and we learned some tricks for giving this information to younger students. Now, we're going to start with a homework example in this video. So, jet planes can exceed the speed of sound. The Mach number describes the speed of such planes. So Mach 2 is twice the speed of sound. Now it gives us the speed of sound. I'm going to highlight that in yellow so we can easily find it because we're going to need it when we do these problems. Now they want us to complete parts A through C. I have a different page for A, B, and C. Now A says if the speed of a plane is described as Mach 3.2, what is its speed in kilometers per hour? Okay, so I'm going to start with what we know, because when you do conversions, that's where you want to start. So we know that we are starting with Mach 3.2. Now, what does that really mean? It said Mach 2 means twice the speed of sound. So Mach 3.2 means 3.2 times the speed of sound. So you know what I'm going to do? I'm going to write 3.2 times the speed of sound. We know that, right? It's 344 meters per second. Okay? Now, if you wanted to multiply that out right now, you could. Or if you want to just keep doing dimensional analysis right here, we can also do that too. So if it makes you feel better, we can multiply 3.2 times 344 right this minute. So now we've got 1,100.8. I'm not rounding it all. Y'all don't round it all in the middle of a problem unless you absolutely have to. And this is in meters per second. Now, let's keep going because, look, they want this in kilometers per hour, not in meters per second. So what I'm going to focus on now is multiplying by a unity fraction. I'm using dimensional analysis, okay? And I want to get rid of meters and change it to kilometers. All right, how do I do that? Remember, if you're trying to get rid of a unit that's in a numerator, then that unit goes in the denominator. Why? Again, so it will cancel out like this in just a minute. Okay, so I need meters in the denominator. What do I need in the numerator? Kilometers, right? Kilometers goes in what I'm trying to change it to. If there's a conversion between the two, you just write it up there. Now, what is the conversion from meters to kilometers or back and forth? Well, there are 1,000 meters in 1 kilometer. And then those meters do cancel. But I'm also trying to change seconds to hours, right? Now, seconds, look, is in the denominator. So that means seconds needs to go in the numerator over here. Why? So my seconds will cancel out. Now what I'm trying to change it to goes on the other side. So hours goes in the denominator. Is there a conversion from seconds to hours? There is. In the first video, you can convert seconds. Seconds to minutes and then minutes to hours. But how hard is it just to know that there's 3,600 seconds in 1 hour? You can go ahead and get it over with in just one conversion. But if you wanted to do it in 2, you go right ahead. But where did I get that from? It's 60 seconds in 1 minute and 60 minutes in 1 hour, which is 3,600 seconds is equal to 1 hour. Okay? Now what do? Well, notice in the numerator, we've got 1,100.8. Now we're timesing it by 1 times 3,600. In the denominator, I have this 1 second times 1,000 times 1. So I'm just going to put 1,000 in the denominator. And look at the units that are left. This is the important part. All of it's important. Kilometers per hour. So I have my answer in the right format. And I'm going to use my trusty calculator over here to type this in and get a result. So it's 3,600 and then divide by 1,000. And I get 3,000 962.88, I didn't round at all, kilometers per hour. Okay, now typically in the problem it tells you where to round. If you need to round, do pay close attention to that. I didn't leave that in the directions. Therefore, I didn't round at all. Okay, that's it. That's what we have. And it was a terminating decimal, so I didn't have to round. Okay, here's question B. If the speed of a plane is described as Mach 4.8, what is its speed in meters per second? Okay, so we take Mach 4.8. I'm just going to write down what I'm starting with. So that's Mach 4.8. All right. Now, what does Mach mean? Again, Mach just means 4.8 times the speed of sound. All right. So I'm going to take my 4.8 and multiply that by the speed of sound, which is right here. That's 344 meters per second. If you want to multiply that out now, you can. As a matter of fact, look, our answer is supposed to be in meters per second. Look, we're already in meters per second. This should have been the first problem, not the second problem, right? This is the easy one. So I got 4.8 times 344, and I get 1,651.2 meters per second. Hey. I know you've probably already figured this out, but when I do the math here, don't just watch. Be writing this on your paper. Pause me. Have that pause ready to go so you can do these calculations yourself, because watching me do it doesn't mean anything. When you actually do it yourself, you get it, right? The physical act of doing this yourself, you really, really get it and go, okay, I got it. No problem. You ready to do C? Now, when I flip over there, here's what I want to do. I want you to pause it. You work this thing out on your own. It is different. You work this out on your own and then come back and let's see if we do it the same way. Or at least get the same answer. It's okay if we do it a different way, but let's get the same answer. All right, how did it go? Notice I got rid of some stuff over here. It tells you how to start the problem. I don't want you to know how to start the problem. I need you to know how to do this on your own. So we're supposed to describe the speed of 5,100 kilometers per hour as a Mach number. Okay, so we need to know what this is in terms of meters per second. That's our deal right there. First of all, we've got to know what this is in terms of meters per second. So let's change 5,100 kilometers per hour to meters per second. Okay, now what do I need to do? Well, I need a unity fraction over here that I'm trying to get rid of kilometers, so it goes on the bottom. Again, whatever unit you have here has to go in the bottom or the denominator of the unity fraction. Okay, and I'm also trying to get rid of hours, but let's just do one thing at a time. The kilometers needs to turn into meters. Now, there are 1,000 meters, you know this drill, and 1 kilometer. But we're not finished, right? But, just to help you feel better, we can cancel those kilometers out. But I've got to get rid of the hours. So I need another fraction. Now, whatever you're trying to get rid of, hours now is in the denominator, so I need to put it in the numerator to be able to get rid of it. And what I'm trying to change it to, which is seconds, is in a denominator. So there's our conversion. Now, how many seconds are in an hour? We've done this drill, 3,600 seconds in 1 hour. Now, where does that leave us unit-wise? These hours cancel with those hours right there. Notice what we're left with is meters per second. That's what we want, right? Now we just need to do the math. So in my calculator, y'all, I'm going to type in 5,100 times 1,000. And then divide by 1 times 3,600, which is just 3,600. So again, 5,100 times 1,000, and then divide by 3,600, and that gives me a result. Now this guy does, it is a repeating decimal. It requires rounding, or you could write it as a fraction. So I've got 1,416, and then 6 repeating, which we know that's 2/3. If we needed to be exact, we'd do it. Now, we're not finished. And I didn't leave myself enough room, but that is meters per second. Now, they want to know that as a Mach number. Now, a Mach number means, see, remember Mach 2 means twice this. So you know what? To change it to a Mach number, we're going to have to work in reverse. Okay? So I'm going to need to divide with this 1,416.6 repeating by the Mach number. Okay? Now notice it just says Mach 2. It doesn't say Mach 2 meters per second. You know why? Because you're taking meters per second and dividing it by meters per second. Mach has no units. Interesting, isn't it? So I'm going to, again, put this whole decimal 1416.6 repeating all the way down the line, divided by 344, and I get 4.118217054. It goes a long way. Now, likely, I didn't read the directions, but likely it might say round to the tenths, hundredths, maybe even thousandths. Let's just say we round to the hundredths place. So this would be Mach 4.11. Okay? And again, those directions do show up in the homework. I just didn't get the rounding directions in this problem. I hope that helped you with some extra dimensional analysis work. I think that's going to carry you a long way with getting some of these problems done. Now let's go back and talk about some properties. We're going to talk about distance properties. You know, distance is the measure of how long something is, right? So the distance between any 2 points, A and B, is greater than or equal to 0, right? Can you have a negative distance? No, you can't. No, you can't. Distance is always greater than, or it could be equal to 0. So notice that a way you can write that is distance is greater than or equal to 0, always. And that's why absolute value is always a positive number, because an absolute value is just a number's distance from 0. And so that's why it's always positive. The distance between any 2 points A and B is the same as the distance between B and A. So they're saying AB equals to BA. If you were considering this as a line segment, it wouldn't matter which direction you're going. Why? Because distance is always positive. For any 3 points A, B, and C, the distance between A and B plus the distance between B and C is greater than or equal to the distance between A and C, written as AB plus BC is greater than or equal to AC. Oh my goodness, that was a lot, right? It's not as bad as you think. Okay, so picture in two-dimensional space the distance between, say for instance, here's point A, and here's point B, and here's point C. Okay, now the distance between A and B would be however long that line segment is. The distance between B and C would be however long that line segment is, right? No curving. These are supposed to be straight lines, but my squirrely screen makes it look all curvy, okay? But what about the distance between A and C? All right, so you could add AB plus BC, but that's longer than going from just A to C. Now, when would they be equal? Why did they have this equal here? Because it is one possibility that they all just line up. So from A to B and B to C, it could look like that. And that would be equal to just going straight from A to C. But if they are not collinear, you remember that word? If they're not collinear, then you end up with this triangle, and that's the same, y'all, as the triangle inequality. We learned about that in a previous chapter. And the triangle inequality says that if you add the green sides over here, it's got to be bigger than the third side. It's got to be. Okay? Now, what if it's equal to? Because this has an equal to there, right? Because this wouldn't create a triangle. If the B collapsed down on this line, you don't have a triangle anymore. So the triangle inequality gets rid of the equal to part. You would also hear this said is the shortest distance between 2 points is a straight line. Instead of going from A to B and then B to C, hey, why don't you just walk from A to C? Speaking of the triangle inequality, here it is, right? So it says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Now notice, again, they got rid of the equal to. Why? Because, look, let's just say BC is the, no, we said AC is the third side. Okay, I'm okay with that. So they're saying AB over here plus BC over here has got to be bigger than AC over here. It's got to be. Just think about walking it. If you walk from A to B and then B to C, that's got to be more than A to C. Why can't they be equal? Because that means B would be collapsed down on top of the line and you wouldn't have a triangle anymore. Okay, so can a triangle be made with sides that are 15 centimeters, 18 centimeters, and 37 centimeters? So a good homework question right there. So look at the longest side. Here's the longest side right here. If we add those together, what do we get? So this is saying 15 centimeters plus 18 centimeters has got to be greater than 37 centimeters. That is the triangle inequality. But check it out, 15 plus 18, last time I checked, that was 33 centimeters, greater than 37 centimeters. Nope, 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 you can't do this. There is no triangle that meets that condition. So there's my no. Not as dramatic as nope, but there we go. Now here's a homework problem that I ran into, and I thought they might appreciate it if I helped out a little bit on this one. So two sides of a triangle have lengths 41 centimeters and 78 centimeters. It says the measure of the third side is a whole number of centimeters. So we're not dealing with any fractional parts of a side, okay? It says what is the longest the third side can be, and what is the shortest the third side can be. It's like, really? Okay, what's the longest it could be and what is the shortest? And I didn't think about this as like two separate questions. What I thought about is the triangle inequality, right? So let's just call them, you got side A plus side B. I'm not writing them as line segments. I'm just saying call them as sides. Has got to be greater than side C, right? It's got to be. Now, there's a couple of ways we could handle this. Am I right? I don't know if 78 is like side C or side B. Well, turns out that's how the longest and the shortest come into play. So bear with me. So first, let's just look at this and plug in one option. Would be 41 centimeters is side A, plus we don't know what B is, and that's got to be greater than 78 centimeters. Okay, so notice what I did this time is I said 78 centimeters was side C, the biggest one, right, of the three. All right, so how do I find out what B is in this case? Well, I use my addition property of equality, and I subtract 41 from both sides, and so that's going to give me B is greater than 78 minus 41 gives me 37 centimeters. So B has got to be greater than 37 centimeters. Now hold that thought. Let's change colors and do this again. Well, what if side C was the one we don't know and 78 was side B? So now I'm changing and I'm going to let 78 be side B. So 41 is still going to be side A. So 41 centimeters plus 78 centimeters has to be greater than C. Okay, well, what's 41 plus 78? That's 119 centimeters. Has to be greater than C. Okay, so now let's think about this. If the missing side, or the third side is what that really is, has to be bigger than 37 centimeters, wouldn't that be like 38 centimeters, right? Has to be bigger than 37. Really, anything bigger than 37 would work, but they told us that we had to use a whole number. We can do that, then 38 centimeters. On the other hand, over here, it says that 119 centimeters has to be bigger than C. So this time C is the third side. So what would C have to be? Well, if 119 is bigger than C, how about 118 centimeters? So basically, our third side has to be between 38 centimeters and 118 centimeters. Now we can answer the question about what is the longest and the shortest it could be. So in red, I'm going to do that. The longest it could be is 118 centimeters, so that's part A, and the shortest it could be is 38 centimeters. That's part B. I hope that'll help you out when you get there. Distance around a plane figure. So if you have a figure, you know what perimeter is? Just the distance around it. If you were going to walk around the thing, how far would it be? So the length of a simple closed curve, or the sum of the lengths of the sides of a polygon. You just add them all up. Okay, it's that simple. So find the perimeter of each of the given shapes here. So on the first one, which we have a triangle, we have an equilateral triangle, don't we? Because all three sides are the same. You know what that means, that all three angles are the same as well, but I'm going into a different chapter. All right, so I'm just going to say 3 centimeters plus 3 centimeters plus 3 centimeters. Of course, that gives us 9 centimeters. That is the perimeter. If you were going to walk around it, here plus here plus here, right? All right, next example. So they didn't give us any measurements. Is that all right? Sure it is. If we were going to walk around this thing, it would be W plus L plus W plus L. You have seen that, I promise, as 2W plus 2L, and that is the perimeter of any rectangle. Did you have to know that formula to get it done? No, you just add all 4 sides together. That's all there is to it. Okay, and then there's their answer, super fast, just so you're confident that we did it right. All right, what is the perimeter of a regular n-gon with side S? Oh, sorry, this is 3 different questions, right? So this down here's the third question. Hey, you pause it, and you find the perimeter of each of these 3, and then we'll come back together and discuss it. How'd it go? Did you get it? Okay, so we got a square, right? How do we know this is a square? Because all 4 sides are the same, and we've got a 90-degree angle, which really means all 4 angles are 90 degrees. So if I was going to walk around this square, it would be S plus S plus S plus S. And if you like to write it out and be like super detailed, because your students will love you forever if you are, that gives you 4S. So the perimeter of a square is equal to 4S. But this guy, we've actually got lengths. Now, how many sides does this have? 1, 2, 3, 4, 5. That's a pentagon, right? It is not a regular pentagon because all 4 angles and all 4 sides are not the same length. But it's a pentagon nonetheless. We've got 3 centimeters. That's my first walk. Plus 1 centimeter. Plus 3 centimeters. Plus 40 millimeters, plus 60 millimeters. Now, y'all, how are we going to add centimeters to millimeters? Well, we're not. We're going to change them all to the same unit. Now, if we were doing homework and we had to type our answer in, the first thing you need to do is look to see what units they want it typed in as. Should I convert centimeters to millimeters? You certainly can if you want to. Should I convert millimeters to centimeters? That works really well on this problem also, because 60 millimeters, remember, we just move over. Remember? Let's do it. So King, I'm moving my screen around. Hold on. Screen is back in position. So King, remember, Henry died, which is DA, by, that's your units, drinking chocolate milk, right? So millimeters is at the end. It's the tiniest, and centimeters is pretty small too, about the size of your fingernail. So if I'm going from, let's convert these two, millimeters to centimeters, I would just move the decimal 1 place to the left. So that's going to change 60 millimeters to 6 centimeters, right? Let's do it right on top of the problem. And 40 millimeters to 4 centimeters. Easy enough. 3 plus 1 is 4, plus 3 is 7, plus 4, that's 11 centimeters. But again, if you were doing this in homework, be really careful, because they might want the answer in millimeters, in which case this would be 30 millimeters plus 10 millimeters plus 30 millimeters plus 40 millimeters plus 60 millimeters, which would give me 110 millimeters. You could do it that way too. So what is the perimeter of a regular n-gon with side S? Okay, now this was a regular square with side S. Really, it's a regular quadrilateral, right? Because all the side lengths are the same. Regular means all the side lengths are the same. And all the angles are the same. So if it was an n-gon, well, if a square has 4 sides and it's 4s, if it's an n-gon, is that not going to be just n times s? Sure it is. So perimeter equals n times s. But this guy's not regular here. We had to know all the side lengths to be able to add that together. Hey, y'all, are you hollering at me to like go back and revisit? I left off one of our sides. It's not 11 centimeters over here. My bad. I'm so very sorry. But I'm glad I caught it before I produced the video and put it on YouTube, and then now you're watching it. By the way, if you find errors in the video, please let me know. I want them fixed. So here we go. 3 plus 1 is 4, plus 3 is 7, plus 4 is 11. Don't forget, plus the 6 over here. Okay, that's 17 centimeters. 17 centimeters. Or if we changed it to millimeters, that would be 170 millimeters, right? Okay, now the reason I caught it so quickly is because I have these nice typed up versions of the answers and they all matched, except over here I had 11 centimeters and that's just wrong. This is 170 millimeters. Again, we decided there was absolutely nothing wrong with saying that that was 17 centimeters either, okay? Because it didn't say what form your answer should be in. So we don't know unless it designates. Now, if that was, say, 65 millimeters or 45 millimeters, I would have done it all in millimeters, so we wouldn't have decimals. But that's still not a requirement. Well, how about the circumference of a circle? You know what that is? That's the perimeter of a circle. How far around is the circle? So you are measuring, if you were to walk around this circle, that's the circumference, okay? It says the set of all points in a plane that are the same distance from a given point, the center, that's the definition of a circle. And I think you've seen that before. Circumference is the perimeter of a circle. Just said that right. What's this pi situation? Well, the ratio between the circumference of a circle and the length of its diameter. So if you know how far it is around a circle versus the diameter, and if you put the distance around on top and the diameter on the bottom, you get pi. And pi is approximately 22 over 7, or approximately, notice the squiggly line's 3.14, but pi is an irrational number. So 22 over 7, again, is like rounded. 3.14 is rounded, although they are very good approximations. Not many applications would you need it more accurate than that. Okay, now, we have a formula here for circumference. Circumference is pi d, or 2 pi r. Okay, now why would they be the same? Now remember what d is. D is the diameter, so it's the distance all the way across, whereas r is the radius. I'm trying to find out what color I want to use. Here's my purple. Okay, r is the radius, and that is just halfway across. So when they say over here 2 times r, that's the same as saying d. So you just do pi times d if you want to use all the way across, or 2 pi r if you want to use just the radius, or which is halfway across. But always the diameter and the radius come from or go through the center of the circle. So let's keep going. You can do problems like that. I think there's some examples coming up, but I don't think you're going to struggle with those at all. Now, next thing I want to define for you is arc length. Now, here we have a formula for arc length. So notice arc length is defined to be just part of the circumference. So we could be finding that arc length right there. So that's whenever you hear arc length, it's just referring to the arc or part of the circle, and we have a formula for that. I would like to talk to you real quick about where that formula comes from. Okay, so you know the circumference of a circle, the circumference is pi times d, the diameter, right? We could also write that as 2 times pi times r, because d is just 2r. So let's focus on this one. That's all the way around the circle, not just the purple part, okay? But think about it in terms of a ratio. What if you just want part of the circle? So what we're going to do is take r, I should have put it at the top of the screen, 2 pi r, and multiply it times the part of the circle that we're looking for, okay? Like a fraction of the entire circumference. So that would give me C is equal to 2 pi r. Now my fraction is going to be whatever my angle is. We're going to call it theta. And what are the degrees all the way around? So theta is in degrees. Say, for instance, this is 120 degrees here. What is the degrees all the way around the circle? You know the answer to this, right? It's 360 degrees. And what we did in this formula is we just canceled the 2 goes into 360 180 times. And that's your formula. So it's pi times r times theta. That's all in the numerator. And then that 180, and that's really in degrees, is in the denominator. And there's your arc length formula right there. Now, I'm trying to be diligent about sticking these videos to 30 minutes or less if possible. So this is going to roll over into a part 3. I apologize, but it will not be 30 minutes. I really just have examples remaining. So you have learned all the material, but if you feel like you need more examples, please come back because I haven't calculated any arc length or circumference or anything like that. So I hope you have a wonderful day. Please reach out if you have any questions whatsoever.